this one will become 2, this one will become 13. 13 minus 6 is 7. And here also we have to borrow 1, this one will become 12. 12 minus 6 is 6. And then here we are left with 1. 1 minus 2 is minus 1. So we just don't write the minus, we just take it as that 1. So this is what we are having. Then this cube root, we have to take care of it. And to take care of cube roots, that means you are going to divide by 3. So what we'll now be doing having here is a cube root. That's 566 times 0.3892 all divided by 467.1. So we'll now divide this by 3. If we should divide this by 3, we are going to have a value of now for us to get the value for this one, this cube root, we are to divide. For us to eliminate this cube root, we'll divide by 3. You know, we are having 3 here. If it is square root, we'll divide by 2. But here we are having cube root. So we'll divide by 3. And to get the answer, what we just do is just that. To get this minus 1, that will be minus 3 plus 2. So what we'll be having is by 3 plus 2.6735 divided by 3. That will give us by 1. Minus 3 divided by 3 will give us minus 1. Minus 3 divided by 3 will give us minus 1. Then 2.6735 will now divide by 3 will give us this value. That is minus 3 plus 2 will give us minus 1. Get this right. Minus 3 plus 2 will give us minus 1. Then we'll now take these 2, we'll now take it as an imaginary value to get our division. That will be 2.6735 divided by 3 will now give us 0.8912. Now, for us to eliminate this square, that will be, we'll now be having something like this. 3 cube root 566 times 0.3892 all divided by 467.1 all squared. So we'll be having to eliminate this square, we have to multiply by 2. 2 times 2 is 4, 2 times 1 is 2, 2 times 9 is 18, so we just keep our 1 somewhere, and then 2 times 8 is 16, 16 plus 1, that's 17, so we write 7, we keep our 1, 2 times minus 1 is minus 2, minus 2 plus 1 is minus 1, so it is not this value that will not find the antilog, will not find the antilog of this, that will now be antilog. That is, we are finding the antilog of this. Antilog of 1 by 1.7824. That will be 78.78. That is our table 2. Antilogarithm of numbers. We'll now check our value. That's 0.78. That's on the second table, continuation of the antilogarithm of numbers. That's 0.78 under 2 difference. Under 2 we are having 6053 under 78 under 2 there. Then we are having 6053. Then difference 4. Difference 4, that's 6. You now add your difference to it. That's 9. 3 plus 6 is 9. 5, 0, and 6. So what we are having here is 6059. Now for us to know where we have to place our decimal points, so what we'll be having is by 1, that's 1 plus 1, minus 1 plus 1 is 0. So what we'll be having is 0.6059, which is our final answer. So from what we've calculated here, we write our 6059. Now for us to know where to put our decimal points. Minus 1 plus 1, that's 0. So put our 0 in front and put our decimal point here to get our final answer. Example number 13. Use logarithm tables to evaluate 0.897 times 3.536 all divided by 0.00247. So the first thing we'll do is we'll create our table, logarithm table. That will be number, then log. We first deal with our numerator, that's 0.897, and then 3.536. The first thing we'll get is our integer for the logarithm value. Once you have a 0 before the decimal point, so it's the number of zeros that will give you the integer, and that's, we only have 1 0 here, so that's minus 1, which is the same thing as about 1. Then here we only have 1 integer, and that's 1 minus 1 will give us 0, so we are having 0 points. So we now, to get the logarithm value, we now take 89 under 7. 89 under 7. 89 under 7. That's 9528. 9528. Now for this one, we'll be taking 35. We'll just disregard the decimal point for to check our table. That will be 35 under 3. 35 under 3. That's 5478. 5478. That will be 5478. 35 under 3. 5478. Difference 6. 35 under 3. Difference 6 is 7. Our difference is 7. So we'll now add this. That will be 5. 5. 8 plus 7 is 15. And that's, we just write 5 and bring our 1 here. That 1 plus 7 is 8. That's 5, 4, 8, 5. 5, 4, 8, 5. So we've been able to get our values. Then we now, multiplication is the same thing as addition, so we are going to add this one. That will be 8 plus 5 is 13. Bring our 1 here. 1 plus 2 is 3. 3 plus 8 is 11. So write 1, bring our 1 here. 1 plus 5 is 6. 6 plus 4 is 0. Is 10. 6 plus 4 is 10. Write 0, we bring 1 to this place. 1 plus 9 is 10. 10 plus 5 is 15. And then we now bring is 15, we write 5 and then bring 1 here. 1 plus minus 1 is 0. 1 plus minus 1 plus times minus is equals to minus, and minus times plus is equals to minus. Minus times minus is equals to plus. Plus times plus is equals to plus. So 1 plus minus 1. We are having 1 plus minus 1 is the same thing as 1 minus 1, which is equals to 0. So we are now having 0 plus 0, that's 0 point. We are through with our numerator, so we bring our answers, we bring it out. All these ones we are still going to use later. So that will be 0.5013. This third column usually comes into place when we are having numerator and then denominator. Then to treat our denominator, we are having sets. This is our next topic, just as we are having here. A set is a well-defined collection of objects or elements. A collection of array trees, mathematical instruments, all negative integers, states in Nigeria, and all quadratic equations with complex roots are examples of sets. A set can be described or defined in the following ways. The first one is by making a list of its members. For example, just as we are having here, M is equals to 60 degrees set square, 45 degrees set square, protractor, ruler, compass, divider. Here we are talking about a mathematical set, that is what can be found in a mathematical set.